And welcome back, guys. This is Chris here with a new tutorial session on manufacturing process. This is part 6 or 7, is it? I forgot already. Anyways, previously I've learned about FEA simulation and how to do an FEA simulation, and in this tutorial session you'll be learning how to use an FEA simulation, right? Like, what do you use with what do you do FEA simulation for? Like, what's the entire point of it, right? It's not just to do for doing, right? How do you use the value you have gotten, right? First thing first, I've stated previously, you see your distribution of your force, right? Of the stress on your entire part. And as you can see, this is a pretty well distributed one. It still has a lot of negative space, which is the blue line here, which is the low stress area. Low stress area is not good because parts are there, it's wasted, right? It's space that is being wasted, that is not being used, right? So it's best if you can get it most towards a yellowish to a green part. And then so next thing is to be able to identify your stress, right? So like in this case, right, my stress, it's below below 14 megapascal. But how do we know where is the stress actually taking from, right? So the stress, right, it could be here, it could be there, it could be anywhere, right? But you need to know where it originates from to be able to solve it, right? What if this is 20 megapascals and not 10, right? It's over the limit. Where do we find it? So for that, you need to go back to our chart options, right? Chart options here, and you will show the maximum annotation, maximum stress point, so that it will show you where is the stress all originating from. So the max stress is here, right? So these two parts is handling all the weight, most of the stress, right? So is there a way to be able to solve this issue? Maybe if I lower it down, it's gonna lower the height here, it's gonna decrease the stiffness, right? With this low moment of inertia formula here, it's gonna decrease the moment of inertia, but it might increase flexibility, right? More displacement. Maybe that's a solution, who knows, right? There's a lot of ways to tackle this, right? And in this case, being able to find a source of the problem helps, right? The other way is you need to know that this is called finite element access. So it's a finite element being the key thing, right? It's finite, it's not infinite, right? So the value here on the legend graph here is not 100% accurate. I'd say it's about 90% accurate, and 90 is not good enough in science, right? 90 is not good enough. You need to plot a graph. You need to be able to plot a graph to be able to show that the value you've gotten in each iteration is converging. That's why it's called convergence graph, right? So that the difference between your previous graph and next graph is roughly the same, so that you know that the value you've gotten is actually 99% accurate, right? And that percentage is roughly 2 to 3%, right? And in this case, how do you plot a graph? All right, how do you plot the graph here? So you need to know the number of elements. Oh, that's a new word. What is elements, right? So elements comes with mesh. So let me just show you this mesh plot, right? So why do you need local refinement? Why do you need all of those? We'll talk about local things. What are those things? Because this is your mesh here, right? This is your elements. Each rectangle here, not rectangle, it's triangles here. See, I'm maybe sleepy. It's 1 o'clock. It's 2 o'clock in the morning. This triangles here, right? Each part, they roughly sums up the forces in the entire area. That's why it's finite element, right? And when you increase your element, right, you increase your tessellation, you decrease your tessellation size, right? You would have more of these triangles, but in smaller size. So it will be, instead of this big, it'll be a very small triangle, like one here, right? It'll be a very small triangle. And what does that do? Your value does not even out over a large area, right? Because it's calculating the entire point on this entire triangle for your force, right? So that's why you need local mesh refinement, right? And local mesh refinement is only possible when you know where the issue is, right? Where you can focus on to ensure that the pressure does not change elsewhere, right? So you know this is your mesh. And then next thing is back to this, right? Where are some elements? How do we check our elements? Now that you know what is an element, how do you check for it? Checking for elements is actually quite easy. Just right click here, show. Checking for elements, you just need to go under your mesh, because you can see your mesh area is. Just right click and go to details, right? Under here, mesh details, you can see total elements. This is only 49k elements, right? So it's very big. Right, this is not really change a lot, right? You can change your mesh quality, right, and so on. So just keep this file first. We need to go and add a new study, right? So we just copy study and call it static 2 from static 1 or blah blah blah. Just press OK, and you know this is static 2. You have all your presets, right, from previously, your cyclic symmetry, your fixtures, your force that's pointing the right way, 220 grams, and so on. So there's no need to change all of this, but what you need to change now is your mesh. So you right click your mesh and you need to apply mesh control. Apply mesh control. Then you know that your forces are all coming here, right? All coming here. So there you can add 3 parts here and 3 parts here, and then you can change your mesh density, right? So this is your, you can scroll this bar, you can see you can change the size of it. Usually I like to go fine, but sometimes the fine, right, like over here it tells you it's 3, the element size is 3, but 3 mm might be big, right? You don't know, right? Maybe not using mesh control will be better, so you need to change it to your own. Usually I like to go with something like 1 at the start, and then you halve it, right? So this is your minimum element size. Minimum element size is half of your maximum element size, and then you want to decrease your element size as you go. The rest, there's no need to change, no need to create more issues for yourself. You can play around with it next time, but for now it's like that. Just create your mesh, and then create mesh for sector entity, and then you'll be able to create your mesh, because you know the rest of it does not matter. So even if you have big element size, for the rest of it, it's not going to matter much, right? Because that's not the main point. And as you can see, this size is definitely way bigger than what's here, right? You can see this is smaller, right? So more accurate. So why is that an issue? It's an issue because this right here is gonna make so that the MPA or the value you get is gonna be worse, right? So it's not very nice. So probably go something like 0.5 and 0.3. Right, and then you want to create mesh, and then you hopefully before this progress, this cyclic symmetry is not working properly, so you need to just apply that again. Not a big issue. Oh, and you can see here the stress is still so big. Why is that? Something's wrong. It's not applying the size properly. I have to put 0.5, 0.3, and press enter. Sometimes it does not apply it properly, so you need to check out for that. Now 0.5, 0.3, and now you can actually create the mesh. Don't know why it doesn't work just now. Yeah, Solidworks is just like that. It's a bit finicky. Sometimes it has issues like that hopefully can be solved with the new update. It's going to take a bit longer now because it's actually working, right? And then you can see, oh, your mesh is now way denser, right? Then you need to run your study again because your results are not the same anymore, because it's not like that. Then you can run your study again because it's the same study. It doesn't really matter. Forces, everything is the same, and hopefully it's gonna take a bit longer now. Yeah, just chill a bit. Then as you go down for your mesh control, it's gonna go even worse, lower and lower and lower, right? So oh, it's done. There we go. You can see, oh no, the pressure is now on a different place. That's not supposed to happen. As you can see, the mesh is now on a different place, so it has a force on a different section, and that's not a good thing. Actually, why is it there? That's so weird. That's very odd. But hey, it is what it is. So if you have an issue like this that changes, it means that your value is not consistent. And if your value is not consistent, it means something is wrong. Why is there 14? It didn't happen on static one, right? But that's just how it is sometimes. So what do? You go back to your file and you try to change it. Can I can't. I can't fill it. Nope, fill it thing doesn't work. Let's change this. Edit definition. XS1. So this is working properly. In this case, we'll just run this again, but just add a bit of tessellation here as well, because that was so odd. That shouldn't be an issue though. It never has been. But usually that case won't happen because you didn't change the size of this, so I think there's an error somewhere. Let's just bump this up back to 8 and 0.5, and we can use this to create mesh and create a mesh again. Hopefully this time you're able to solve it better. And then it's done. Then you can run the study. Hopefully there's not too big of an issue. Run the study. And it's gonna take a bit while. We can hear it, my computer is burning a bit. It's a bit hot. But that's just how it is. So as you go lower and lower, it's gonna be worse and worse. But anyways, so you know how to plot your elements, you know how to plot your stress level, right? And then you just need to plot it on a graph, and then you calculate the difference. If the difference is less than 2%, then it's okay. Oh, now it's 20. So obviously there's something very, very wrong here. I think that has to do with my file. So you need to change that. So you can find a lot of weird things here. So if this is an issue, then you need to solve the issue. Let me see if we can deal with this. Why is there so much stress level here? It's so odd. But anyways, you can see that would be the issue. And then if the stress level is moving up, there's something wrong. You want to copy the study again, and then you want to do the same thing but with a lower mesh control, like lower size of your mesh. So 0.5, 0.2, then you want to apply that, create mesh and calculate, and hopefully that force will go up again. There's something wrong there. This one is a model issue, so I think I need to change something about the model, yeah, to fix that issue. It is very odd calculating parts like that. And then you want to do your study, and if the difference once you plotted it is less than 2%, you are off to go, right? Then now you run the study this time, and then you do static 2, static 3, static 4, and so on until either your computer can handle it or you reach your convergence graph. It's that simple, right? And you just learn local mesh refinement and learn how to use FEA analysis to your ordeal. Unfortunately, I couldn't get the value right for this case, right? Unfortunate, but it is what it is. And you can see this part is still the issue. It's getting worse and worse, and somehow and somewhere there is the issue here. that is causing the stress level to go very, very high, right? Even though the rest of the part should be okay. Yeah, and hopefully this helps you out a bit, so that um, I can't really teach you how to solve this. You just need to work it out and test things out, but at least you know where the problem is and you have a foothold to stand on. And once you're able to plot your convergence graph using a graph editor here, right, and then you can find your final stress value and convergence at less than 2%, then you know it's a roughly there. So it could be roughly 12 MPa and below, right? And then so that's it. That's your entire mesh refinement, entire cherry study, and hopefully this tutorial helps. Unfortunately, again, could I get the value, right? But it is what it is. Sometimes tutorials are like that, and this is a rush book, so I couldn't get it done. Apologize for that. Anyways, hopefully you guys have learned something, able to use this for your exams and your courses in the future, and hopefully this helps out. Thank you. Bye bye.